Sometimes the best way to compare two options is to test them in a fair and balanced way. Randomized experiments help us do that by making sure that each group gets treated equally. In this lesson, we'll look at data from these kinds of experiments to see how we can use it to make clear, unbiased comparisons. Let's take a look at an example where researchers conducted an experiment to test the effectiveness of two different fertilizers, fertilizer A and fertilizer B, on plant growth. They planted 20 identical seedlings and randomly assigned 10 of those to receive fertilizer A and 10 to receive fertilizer B. After 4 weeks, they measured the height in centimeters of each plant. So we're going to use the plant growth data to compare the results using Google Sheets. So we're going to do three things for fertilizer A and fertilizer B. We're going to calculate the mean, the standard deviation, and make a histogram for each one. Now for the mean and standard deviation, we're going to use formulas. So I'm going to click on an empty cell, and formulas always start with an equal sign. So I'm going to type equals, and then for the mean, we type average. And then we can choose from the list if we'd like. And then I'm going to highlight the data that I want it to average. And I close the parentheses and hit enter. So equals average, highlight the data, close the parentheses. And it tells us the mean of the plant height for fertilizer A. So let's do the same for fertilizer B. Going to start with an equal sign, and then it's average. So I'm going to start typing average, and then I can just click on it there, highlight the data, close the parentheses, and hit enter. So we notice by calculating the mean that the plants in the fertilizer B group were taller. All right, let's calculate the standard deviation, which is a measure of spread. So always start with an equal sign for formulas, and it's STDEV, and we have several choices here. We want standard deviation for a sample, so it's .s. Because we're not looking at all plants here, we're just looking at the 10 that were in the sample. So I'm going to highlight my data, close the parentheses, and hit enter, and I get the standard deviation. For fertilizer B, I start with an equal sign, start typing standard deviation, or STDEV, and I want STDEV.S. Highlight the data, close the parentheses, enter. And we notice these standard deviations are about the same. All right, let's make some histograms here. So I want a histogram for fertilizer A here. So I'm going to highlight, I'm going to include that table heading there. So I highlight the data, I go to Insert, Chart. Now it's suggesting this scatter chart, but we want to change that to histogram. So here it is, histogram. All right, so now in this menu we have Setup and Customize. There's one thing that might be helpful in Setup to change, and that's to specify the x-axis. This helps with certain settings. So I'm going to click Add x-axis, and choose plant height. So that's my x-axis. All right, let's go ahead and customize this title. So I can just click in there, and I'm just going to call this chart Fertilizer A, because the axes are going to have labels also. So I want to clarify that this is the histogram for fertilizer A. Let's customize the horizontal axis here. This is plant height. Now I'd really like to have a label for the vertical axis. So in the Customize menu, Chart and Axis Titles, I'm going to change this second drop-down menu to Vertical Axis Title. And the title I want for that is plants, or number of plants. And there's my vertical axis title. Now on the horizontal axis here, I'd like that to go by whole numbers. So I'm going to change that. Oh, one other thing up in histogram. It's really hard to notice here, but in the histogram section, it says bucket size. Now, for this data, if we move this aside for just a minute and look at the data for both the groups, it looks like they don't get any smaller than maybe 11.8, and they don't get any bigger than 15 point something. All right, so for my bucket size, we don't have to go very far, so I'm just going to choose 1. So now I'm going by ones, but now I want the starting value to be different. So for that, we go down to horizontal axis. And let's have the minimum value be 11. And the maximum value, I'm going to go a little bit past where I want it to go so it doesn't cut off the last label. And now we have our histogram. One other thing we can do is get rid of these decimals here in this axis. So I'm going to go back to horizontal axis and go way to the bottom. And number format, let's choose none and see what happens. There we go. That's better. All right, so now I'll shrink this. Move it right here, and let's make a histogram for fertilizer B. So I'm going to highlight the heading and the data, go to Insert, Chart. This time it knows I want a histogram. Let's go ahead and custom it. We want the main thing here is we want the axes to be the same for both histograms. Let's see, let's change the title. This is fertilizer B. In setup, I'm going to add my x-axis by just clicking on plant height. I'll go to customize. For the bucket size, we want to do the same thing we did on the other one. So I'm going to change my bucket size to 1. I'm going to add my vertical axis label, number of plants. Go to horizontal axis. And I want the same minimum and maximum. So let's do 11. I think we did 17. And number format, I want to get rid of these zeros here. So number format, I'm going to change it to none. There we go. The y-axes or vertical axes are a little bit different. So let's go ahead and fix that. Let's change this one to go to 5, just like these here. So I'll go to vertical axis, minimum value 0, maximum value 5. So when we're comparing two things, we need everything to be the same. All right, so the horizontal axes are scaled the same, and so are the vertical axes, and now we can compare the results for fertilizer A and fertilizer B using the mean, the standard deviation, and these histograms. So X bar, that's our abbreviation for the sample mean, and the mean from the sample for fertilizer A was 12.5 centimeters. And the mean height for the fertilizer B group was 14.4 centimeters. Little s, that's the abbreviation for the sample standard deviation. It's a measure of spread. And that was 0.502 centimeters for the fertilizer A group and 0.596 centimeters for the fertilizer B group. And the two histograms. So we have the sample mean, the sample standard deviation, and the histograms, and we're going to use those to make a comparison. So let's summarize those things. The mean plant growth for the plants using fertilizer B was higher. And that was, let's see, X bar for A, or the sample mean for A was 12.5. And the sample mean for B was 14.4. Let's make a comment about the spread of the distributions. We could just say the spreads are about the same. The sample standard deviation for group A was about 0.5, and the sample standard deviation for group B was about 0.6. Now for the histograms, we could say both distributions were roughly symmetrical. With a peak in the middle. And no outliers. Those are the unusual values. Okay, so let's make the best conclusion we can make with this, keeping in mind that we only had 10 plants for each fertilizer. So the results of this experiment provide some evidence that plants grow taller with fertilizer B. Now, a good way to follow up this experiment would be to ask a statistician how certain we should be of this conclusion. All right, let's review some of the things we did in the spreadsheet. To find the mean, we typed equals average, and then we highlighted the data and closed the parentheses. To find the standard deviation, we typed equals stdev.s for standard deviation of the sample, and we highlighted the data and closed the parentheses. To make the histogram, we highlighted the data in the column, we clicked Insert, Chart, and then changed it to histogram. In the histogram setup tab, there's a little technical issue that just kind of makes things a little bit easier to work with. We went to series and we chose the x-axis. And in the histogram customize tab, we went to the histogram area, found the bucket size, and set up a bucket. In that case, it went by ones, but we might want to go by fives or tens or something. Then we changed the chart and axis titles so that they are nice and descriptive. And in the horizontal axis section, we changed the minimum and maximum and number format so that both histograms matched. We want both of the horizontal axes to have the same min and max. And same thing on the vertical axis. We want those to have the same min and max since we're comparing them. All right, after this presentation, I hope you're feeling more ready to go compare two distributions with Google Sheets. This is Mr. Ela, signing off.